Welcome to the CompTIA Project Plus Prepcast by baremetalcyber.com. In a well-structured project schedule, every single task should connect to at least one other task. These connections are not arbitrary. They define the logical order in which work is executed, creating the backbone of the schedule's sequencing. Successor and predecessor relationships guide the flow of work, helping the team understand not only what needs to be done, but in what order and under what conditions. This structure gives the project manager a clear map of dependencies, making it easier to identify risks, allocate resources effectively, and maintain overall schedule integrity. Without this relational logic, schedules become a loose list of dates, vulnerable to missed connections and overlooked constraints. A predecessor is a task that must either start or finish before another task can proceed. It controls the timing of its successor and forms one half of the dependency link. Predecessors can be necessary for many reasons: technical sequencing, resource availability, or organizational policy. For instance, in construction, foundation work is a predecessor to framing. In software, coding is a predecessor to testing. Incorrectly linking or omitting predecessors can cause misalignment in schedules, resulting in idle resources, rework, or tasks starting before prerequisites are complete. A successor, by contrast, is a task that follows another task's start or finish. It relies on its predecessor to meet defined conditions before it can begin or conclude. Successors give forward motion to the schedule, forming the chain of activities that ultimately leads to project completion. They are especially important in tracking downstream impact. If a predecessor is delayed, all linked successors are affected. This makes the successor's performance a direct indicator of how well the schedule is holding together. The most common relationship between predecessors and successors is finish to start. In this arrangement, the predecessor must finish before the successor can start. It's the default in most scheduling tools and represents the natural, intuitive flow of work. For example, in manufacturing, a machine part must be fabricated before it can be assembled into a product. While this structure keeps sequencing clear, it also means that any delay in the predecessor will push back the successor's start, potentially impacting the overall timeline. Start-to-start relationships allow a successor to begin once its predecessor has started. This approach enables tasks to run in parallel, compressing timelines when time is tight. For example, you might start writing user documentation once software development begins, rather than waiting for the final code. However, this requires strong coordination to ensure the successor does not advance too far ahead, relying on incomplete or changing predecessor work. Finish-to-finish constraints mean that the predecessor must finish before the successor can finish. This is used when deliverables need to conclude together, even if they start at different times. A good example is finalizing a report and its associated graphics. Both must be completed before the report can be published. This relationship is often used to align review cycles, multi-component testing, or phased approvals. Start to finish is the rarest form of task relationship. In this case, the predecessor must start before the successor can finish. It is typically used in specialized operational contexts, such as staffing a 24-hour facility, where one shift cannot end until the next has started. While uncommon, this relationship can be critical in environments that require continuous coverage or tightly timed handoffs. Many tasks have multiple predecessors. Integration testing, for example, may require that development on several modules is completed before it can start. In this case, all listed predecessors must meet their conditions before the successor begins. While this is sometimes unavoidable, having multiple predecessors increases complexity and risk, as delays in any one of them can hold up the entire successor task. Similarly, one task can have multiple successors. The approval of a major design might trigger the start of manufacturing, marketing, and documentation tasks all at once. In such cases, the predecessor's completion date is a single point of dependency for multiple streams of work, meaning that a delay has a wide ripple effect. Each successor must be tracked individually for progress and resource needs. Managing these relationships in scheduling software allows project managers to define, visualize, and adjust task connections. Tools like Microsoft Project or Primavera P6 offer both Gantt chart views for visual timelines and network diagrams for logical sequencing. These tools also flag logic errors, such as circular dependencies, which can lock schedules in unsolvable loops. Regular review of these relationships in the tool helps keep the schedule realistic and aligned with the project's evolving reality. During the sequencing phase of schedule development, each task is examined for its logical position relative to the others. Predecessors and successors are assigned deliberately based on the project's scope, estimated durations, resource availability, and technical dependencies. The goal is to produce a schedule that is not only logically correct, but also executable in the real world. This process often involves collaboration with subject matter experts, functional managers, and team leads to ensure that the order of activities reflects the way work can and should actually be done. Every relationship should be scrutinized for its role on the critical path, as tasks that drive project completion require extra attention. As the project progresses, these relationships must be reassessed regularly. Real-world conditions can reveal that some dependencies are no longer necessary, or that new ones have emerged. For example, if a prototype build is completed earlier than expected, downstream tasks like quality inspections might be able to start sooner. Conversely, a delay in acquiring materials might require the resequencing of multiple successor tasks. Regular schedule reviews allow the project manager to update relationships so that the plan remains an accurate reflection of the current state of work. Lead and lag adjustments are powerful tools for fine-tuning these relationships without changing the underlying scope of tasks. Lead time allows a successor to begin earlier than the standard dependency would normally permit, creating intentional overlap. This is common in situations where partial completion of a predecessor is enough to begin work on a related task, such as starting system configuration before all hardware is delivered. Lag time, on the other hand, introduces a planned delay between tasks. This can be critical for curing times in construction, mandatory review periods in compliance-heavy projects, or waiting for approvals. Both lead and lag should be applied deliberately and documented to prevent misunderstandings. Validating the integrity of these relationships is essential to schedule quality. Every task should connect logically to the rest of the schedule with at least one predecessor and one successor, except for the first and last tasks in the project. Loops, disconnected tasks, or excessive use of leads and lags are red flags that suggest flawed planning. Validation may involve automated checks within scheduling tools, as well as manual reviews by experienced planners or the project management office. A clean relationship structure ensures that schedule updates and critical path calculations remain reliable. In many projects, tasks are owned by different teams, departments, or even organizations. Cross-team dependencies must be clearly documented and communicated, because delays or misunderstandings in one area can cascade into multiple others. Handoff points, deliverable acceptance criteria, and timing expectations should all be agreed upon in advance. Without explicit coordination, a task that one team believes is done may not meet the needs of the next team in the sequence, causing costly rework and schedule slips. External dependencies introduce another layer of complexity to successor and predecessor relationships. When tasks rely on vendors, clients, or third parties, the project manager's control over the timing is reduced. These external links are especially vulnerable to delays, and their status must be monitored closely. Buffer time or contingency planning is often built into the schedule to protect critical successors from the impact of late deliveries, missed approvals, or regulatory reviews. The visibility of these dependencies in the master schedule allows for proactive risk management. Tasks on the critical path that serve as predecessors to other critical tasks require the highest level of monitoring. In these cases, any delay in the predecessor will directly impact the successor and ultimately push out the project completion date. These relationships have zero float, meaning there is no flexibility without affecting the end date. The project manager should prioritize these tasks in progress reviews, resource allocation, and risk management efforts, ensuring they receive immediate attention if problems arise. Not all relationships are this rigid. Tasks with float have some flexibility in their start or finish dates without impacting the overall project timeline. These non-critical relationships can provide breathing room in tight schedules, offering opportunities to adjust for resource conflicts or unexpected events. However, float is not a license to ignore these tasks. Misuse of flexibility can erode buffer time and create new risks. Preserving float through disciplined scheduling practices helps maintain overall stability. Communicating the impact of task relationships to stakeholders is an important part of project transparency. When reviewing the plan, stakeholders should understand which activities drive the timeline and how delays in predecessors can affect downstream work. Visual tools such as milestone charts, dependency maps, or network diagrams can make these connections easier to grasp. Clear communication builds confidence that the schedule is logical, realistic, and managed with discipline. Whenever scope changes occur, whether through formal change requests, client requests, or internal strategy shifts, the entire web of relationships must be revalidated. Adding, removing, or reordering tasks can significantly alter the structure of predecessors and successors. If these updates are not made, the schedule will no longer accurately forecast the project's future, leading to missed commitments and resource conflicts. The work breakdown structure, schedule, and resource plan should all be updated in parallel to maintain alignment. Auditing task relationships periodically is a best practice for ensuring schedule health. These audits can uncover broken links, circular dependencies, and unnecessary constraints that reduce flexibility. Many project management offices use relationship integrity as a quality metric when assessing schedules, recognizing that a clean, logical network is the foundation for effective planning. In professional practice and on the CompTIA Project Plus exam, being able to explain, create, and maintain high-quality predecessor-successor structures is a hallmark of competent scheduling. In summary, the disciplined use of predecessor and successor relationships is what transforms a collection of tasks into a functioning project schedule. By establishing logical sequencing, applying leads and lags effectively, validating connections, and managing cross-team and external dependencies, the project manager ensures that the schedule remains both realistic and adaptable. Mastering these concepts enables better forecasting, more efficient resource use, and stronger on-time delivery performance, all of which directly support both exam readiness and success in real-world project execution. Thank you for listening. Please follow baremetalcyber.com on social media and check out our books at cyberauthor.me.